Hey there, Rajat here. In this video, we are going to learn about Docker, and we are going to learn Docker in the context of web development, because web development is one area where Docker has seen quite a lot of adoption. So as you can see on this particular chart, Datadog has done some adoption research and they have discovered that quite a lot of company have started using Docker in their production environments, and as a web developer it becomes quintessential to understand what Docker is and how to use Docker to greatly reduce the deployment pains. So let's start with the problem. Why do we even need Docker? So in your day-to-day application development, when you are ready with your code, you need to deploy it onto the server so that it can be served to the end user. So this is a normal flow we follow as web developers. So if we have developed a Node.js application, this would be our setup. We would first have a VM running any Linux-based operating system. Then on top of that, we will install Node.js, and then we will put our files onto that server, and then we will ask Node.js to run our programs. And then Node.js in conjunction with system files will create an environment, and it will translate your program into machine instructions and hand it over to the kernel. So the kernel can ask the bare metal to do its job. So that is how your application works. Now, in this particular case, there is a complication that whenever you try to install your application on a new server, you have to ensure that all the dependencies, like in this particular case, Node.js, are installed on the server, and then only you can run your programs on top of that particular environment. So this is a hard requirement which you have to follow if you want to run your application. Now, in this case, we only have Node.js as the dependency. Let's suppose we are deploying a full-fledged full stack application where we have a database, a backend application, and a front-end application. So in that case, we will have Node.js and some database like MongoDB, and the front-end application may be built using React or Angular. In that particular case, you need to have some other dependencies like Node.js, MongoDB, and then some Next.js server or Angular server. So all of those things should be installed on that particular machine, then only your code will work. As a developer, there can be a possibility that when you hand over your code to the IT guys, they will forget something, that they will forget installing MongoDB, and then they bring up your application and then it won't work. So this thing can create problems in the deployment cycle. So what you can do, you can package your entire application along with the runtime into a single package, and then you can take this package and put this thing on any machine which is capable of running Docker, and then Docker will take that particular package and host the entire application for you. This way you put your configuration in code and you create an artifact out of it which is distributable, as you can see in this particular diagram. So we have the machine which is running the kernel. Then instead of using the system files are packaged along with the runtime and the actual program. So we have created an artifact, as you can see up top. This artifact is distributable, which means that you can store it on any media, and then you can distribute it to other people, and then other people can take this artifact and run on top of Docker. So Docker makes it portable. So Docker sits on top of your kernel, and then it takes this particular artifact which has everything it needs to run your application and executes it on top of kernel. So what happens is that this Docker uses your underlying Linux kernel in order to achieve this task. So there is a hard requirement that Docker can only run on top of the Linux kernel because it is a Linux related technology. You can install Docker on Windows and Mac OS, but in that particular case, it is actually installing a virtual machine which is running Linux, and then Docker is administrating all the activities inside that particular virtual machine running the Linux image, and that is how you are able to run it on Windows and Mac OS. We are going to see that in action later on. So we have talked about the artifact. In Docker, it is known as an image. So a Docker image is a distributable artifact which can be stored anywhere. So basically it contains the system files that are required for running your program, the applications or the dependencies. As we can see in this particular case, it is Node.js along with your actual program that you need to run in that particular environment. So all of these files are packaged into a binary or an artifact, and then that artifact can be shared. Like you can give this artifact to your IT team and they can run it readily on top of Docker, and it will work without any hassle. So when you run this image on top of Docker, it becomes a container, as you can see here. So from a single image, you can spawn as many containers as you would like. So basically a container is a running instance of an image. As you can see here, from this particular image, we have spawned two similar looking containers. But one thing to notice in this diagram is that both of these containers will have their own environments. They will be executing in isolated environments, so they won't be sharing anything. Even if they are sharing the image, the running instances, the running containers will have their environments totally isolated. So that is how Docker makes your app portable. So you must be wondering, how does Docker do these things like creating the image, then using that image to create the container, and then running that container on top of the Docker installation? For that, we have to install Docker onto our system. Now there are two ways to install Docker. The first way is to install the Docker CLI, known as Docker Community Edition. Now this will only give you the CLI tools, and this thing will only run on top of Linux, because for Windows and for Mac OS you would be required to download Docker Desktop, because we have already learned that Docker is a Linux related technology. It uses Linux kernel to do its job. And since Windows and Mac OS are the operating systems which are not based on Linux kernel, the Docker cannot run natively on these systems. For that, we need Docker Desktop, which is basically a virtual machine which is having Docker C installed in it. So it will create a virtual machine, and inside that virtual machine it will install Linux kernel, and then it will install Docker CE on top of that Linux kernel. So whenever you run your application inside Windows or Mac OS, actually you are running your applications inside that virtual machine which is running the Linux kernel. On top of that, Docker Desktop also gives you sort of a graphical user interface. Since I am on Mac, I am using Docker Desktop, but in case you are on Linux, you do not have to install Docker Desktop. You can install Docker CE. In order to install this thing, you should head over to Docker's official documentation, because Docker community keeps on updating its documentation in order to keep it fresh. So if I show you how to install Docker, it will become obsolete real soon. So I will skip it. You can head over to Docker's official documentation in order to install this thing. You can pause this video here. You can go to Docker's official documentation, see the official documentation, follow the instructions, and download Docker onto the system. Once you have Docker installed on your system, then you can unpause this video. So let's see what you actually get when you install Docker on your system. So Docker is a client server based application, and the client is responsible for taking in your commands. So whatever commands you run on the CLI, you are actually running those commands, or you are issuing those commands to the client. The client will take in that command, and that command will be shipped over to the Docker daemon. Now Docker daemon is responsible for managing the resources on the machine it is installed on. So it will take care of downloading images and spawning new containers, deleting containers, and things like that. Also, it will download images from the registry. We have learned that the images are distributable artifact, and those images can be shared. So basically we have a registry or a central place on the internet where these images can be put on and downloaded from. So hub.docker.com is that central repository for finding Docker images. So in case you want to download a Docker image for MongoDB, you can find it over here, and you can create an image of your application and put it onto the Docker Hub for the world to use. Now here you see that it is demarcated as official image, which means that companies can put their official images onto this repository, and then other people can see that okay, this is the official image and download it from there, because it is an open platform and anyone can put applications on this platform. So in order to show that this particular image is coming from a real company, these guys show badges like these. So almost anything you can think of can be found over here. You can find Node, you can find Python. So these are images basically which have the Python language installed on it already, and you can take this particular image and run your application on top of this particular image. That was the registry part, and Docker daemon can pull in the images from the registry. Now the hub.docker.com is the official registry for Docker images, but in case you want to use your own Docker registry, you can do that. Azure Container Registry is a really popular choice. People use it in order to host private images where you do not want the world to download your images freely. You can put it behind a authenticated wall, and then only you can download the images from there. You have to provide in the authentication in order to do that. So now that we understand the basic architecture of Docker, it is the time for some hands-on, and for that we can start with downloading images from the registry. So what sort of image can we download? We can head over to hub.docker.com and search for Busybox. So this is the smallest image you can find on the Docker Hub, and basically this is just a collection of really common Linux commands. So commands like ls, cd, cat, make directory are included in this particular image, and you can use those commands in order to do your job. If you head over to the documentation, over here you will get to see how to pull this image onto your local system. So we can copy this and paste it in our terminal. So this will pull the Busybox image from Docker Hub onto your local machine. Now if I do Docker images, I will get to see that these images are located on my system, and I can see the size. So you can see that Busybox is only 3.73 MB. The tag denotes the version. So basically it is just like any software that it is versioned. They keep on releasing new versions. So whatever version is the latest is tagged with this latest tag. I have also downloaded MongoDB, so it is also getting listed over here, but in your case it would be this only. Now that we have downloaded this Busybox, we can try running this thing. So in order to run this thing, we can type in docker run to run this thing, and then we can choose the image name, and it has run this thing, but nothing happened. Why? Because it is a really simple image which actually does nothing. So it has finished running and it did not produce any output, because that is the use case for this Busybox. It is just a collection of a few utilities and it does not run anything on its own, but we can make it run something. So let's do one thing. We can run this thing into an interactive mode. For that we have to use this flag IT, that is the interactive mode, then the name of the image that we want to run, and then the name of the program from that particular image that we want to run. Since we know that Busybox is a collection of several utilities, this shell bin sh is also included in Busybox, which we can run. So we are instructing Docker that run this particular image in the interactive mode, and when you spawn this container, run this particular command. So if we do this, we will be dropping down to this shell, and this shell is inside this container actually. If we do ls, we will see that we are in here. If we do who am I, we will see that we are in root. So basically we are inside this Busybox container now. We can open up a new terminal and see docker ps. This will list all the containers that are running. So this is the container ID. This is the image using which this container was created. This is the command that is getting executed right now. And this shows the duration that has elapsed since the creation of this thing. And it says the status, it is up. Then the ports, we will talk about it later on. And then it is showing the name of the container. Basically you can provide the name to the container. So we are in this particular container as of now, and we can run whatever command we want to. So all the basic Linux commands are available in Busybox, but again it does not do much. Let's exit this application, and if we do docker ps now, the application has stopped because it only was running in the interactive mode, and we have ended the interactive mode. That is why the container has exited. Now we know what images are, what containers are, how to pull the images, how to create containers, and how to get the status of the containers. How about we create a small image for ourselves? So let's just create a small application and put it inside image. But what should that application do? That application would be really simple. It would just list down the content inside the data directory that is mounted on that particular machine, and that is it. So in order to create that sort of an application using Docker, we first have to create a Docker file. So I will first create a directory called Busybox list, and inside this Busybox list I will create a Docker file. Now Docker file is the blueprint for your image. So whatever image you want to create, you put the instructions inside this Docker file, and you have to run a certain command in order to create the image using this Docker file. So we can start editing our Docker file. This Docker file will be responsible for creating our image, and every image, it starts with a base image. So base image is just like the starting point for your image, because you have to start from somewhere. You have to start from the operating system, or you can start from some intermediate image. In our case, we are going to start from the Busybox that we have already seen. So if we start from Busybox, we can be sure that there will be certain utilities that we will find into our image. So if we start from Busybox, we can be sure that ls will be available, because in Busybox we have already seen that ls was available. And now what we can do this thing, ls-data, and that is the thing that we want to do. In order to run this command, we have to use the cmd clause, which means that whenever this image is run, this particular cmd command will be executed. So the first member of this command will be the actual command that will be run, and then comes the flex. So we want to run ls-ltr, and it should run on the data directory, because we want to list down the content of the data directory and in a tabular format. So list all the contents inside the data directory in the tabular format. Okay, so this is a real simple command, and this is our image. This is what we want our application to do. Since we have created the file, now is the time to create an image out of this Docker file. In order to create an image from this Docker file, you can run docker build, then the tag. So the tag will be the name or the identifier of that particular image. So if you do something like Docker images, you see all these tags. That tag we can provide using docker build -t. So this t is this particular tag. So we can call it Busybox list, and then the tag, it will be something like 0.1, because as of now we are simply testing the alpha build of our application. That is why this 0.1 version or the tag, this is image's name, and then the colon, and then the version, and then you can provide the context. So context is the directory where the Docker file is located, from which it should build the image. So since it is located inside this current directory, we are simply going to provide it a value of dot, which is the current working directory, and then it will build our image. So the image has been built, and we can query it docker images, and as we can see, we have built our image. Now we can run this particular image or put it onto any registry in order to use it, or in order to let others download and use it. So let's try to run this thing, docker run Busybox list. If we do that, it will try to find the latest tag, but we haven't created the latest tag. Since it cannot find the latest tag on this local machine, it is going to go onto Docker Hub in order to find it, but we do not want that. In that case, we have to do docker run Busybox list and then the version number. Then it will be able to find it on our machine, and as you can see that the command has failed because the data directory wasn't there. How can we check this? We can again go inside this image in the interactive mode, because it is based on Busybox, and we already have seen how to log inside Busybox. So we are going to do that same thing over here. So we will run docker run it Busybox list and then bin sh, and we are dropped onto the shell, and we can try running this command from here. That's what we are trying to do from the image itself, and it won't work simply because slash data is not yet there. So we have to have this particular mount point, then only it will work. How can we do that? For that, we can create a Docker volume. Now Docker volume is a space on your drive which can be mounted inside the Docker container as a normal disk. Let's see how we can create a Docker volume. So using Docker volume ls, you can see what volumes are there on the system. So let's say we want to create a volume called Busybox data in order to mount it onto the Busybox application that we have created. We can do Docker and then volume and create, and we can call it Busybox data. This will create the volume. Again, we can do Docker volume ls and Busybox data will be created for us. If we want to see where this Busybox data is going to be located onto our disk, we can do Docker volume inspect and then the name of the volume Busybox data, and the data for this volume will be stored inside this. So Docker is going to manage all of these things. Again, all of these things are happening using Docker daemon, which is taking care of managing all these resources that are there on my system. Now that we have the Docker volume, we can mount this thing on our container. Let's see how to do that. We can use the same command, but here we will now mount our volume. So we will do Busybox ls or Busybox data, that is the volume we have created, colon, and then the mount point where we will like to mount this volume, and this thing will be mounted inside the container. So let's see if we do that. This time our application will work because now this data directory was mounted on top of that. Again, we can launch the application in the interactive mode and see for ourselves whether this volume was mounted to the data directory or not. So bin sh, we will be dropping onto the shell, and if we do ls/data, it is indeed located over here. So you can do df-h and then you can see that this data directory is loaded on the machine. So that is how you can mount external drives as well on your containers. We can exit this application now, but these were really trivial applications. This is not what you are going to use Docker for. You are going to use Docker in order to containerize your Node.js application, your Go application, your Python applications. So let's containerize, let's Dockerize a Node.js application. Let's Dockerize this particular Node.js application. Now I have demonstrated how to create this application on one of my playlists on this channel itself. So in case you are interested in learning how to create a Node.js application from scratch, you should watch that video. The link will be somewhere up here. You can check that out. And let's first of all download the code base on our system. Again, we can create a new directory, or we can just simply switch to a blank directory and do git clone. This will download the application on our machine and we can cd to it, express tutorial. So here is our application. So let's Dockerize this application. We have to create a Docker file, and we can open this Docker file in the text editor. Again, we are going to start from a base image. In this case, we are going to use the base image of Node. So here Node.js is installed inside an image which can be used as a starting point. So we will use this thing from Node and version 20 because that is the current version as of now. Now we have to create a work directory. So the work directory is going to be app. Now this work directory will represent the directory where all the source code of your application will be contained in, and which will be used as the starting point when the image is booted. So the image will use this directory as the starting point. If this directory is not there, Docker will ensure that at the time of the creation of the image, this directory will be created on its own. Now we need to copy essential files from the local machine onto the image. So we will do copy package.json. So this is a Docker command. So this will copy package.json onto app. Now this slash is important. This will indicate that it has to copy package.json inside this app folder, or you can simply do package.json explicitly. Again, you have to copy package lock.json, app package lock.json. Then you have to copy the application files, app index.js, copy book router.js to app book router.js, and then we have to run npm install in order to install the node modules inside this image. Now this run command will execute whatever is written after it. After doing that, we have to start our application. For that, we can again use cmd node and then the name of our program. We can do index.js. So our Docker file has been written, and now is the time to create an image out of this Docker file. Again, we can do the Docker build thing, Docker build t, the name of our express application, that is express app, and then the tag again is going to be 0.1 because we are simply testing as of now, and then the context. Again, we are in the directory where this Docker file is located. So the context is going to be the present working directory or a dot, and then let's create the application. As you can see that now it is building the image. It is downloading node 20 image on this machine, and then it will create the layers on top of it, because Node.js will be used as a starting point, and then it is going to build layers on top of it, because a Docker image is a collection of several layers and these layers can be cached. That is how you are able to use any image as a starting point, because that thing is a collection of layers, and whatever you are going to build on top of that particular image is also going to be a collection of layers. As you can see, it has copied our files onto the image, and now it is running the npm install inside the image. So our image has been built. Let's see Docker images, if our image is there. So our image is here, express app. Let's see if we can run this thing. So Docker run express app, then 0.1, and let's see if it is running. As you can see that our image is running, or you can say that our container is running, because the runnable instance of an image is known as a container. So as you can see, the server has been started at port 3000. Let's see if we can access our application on port 3000. So if we go to localhost 3000, we cannot actually connect to the application. And why is that? It is due to the fact that the application is running inside the container on port 3000, but container has not exposed the port onto the host machine. That is necessary in order to access the application on the host machine. You have to map port from your container to the actual machine or the host machine in order to access that application. Let's see how we can map ports. So we know that our application is running on the 3000 port. We can try pressing Ctrl C in order to terminate the application, but it will not terminate that way. For terminating the container, what you have to do, you have to first of all see if the container is running, and by running docker ps command you can get the container ID. Then you can do docker stop, then the name of the container, then the application will be stopped, and then only you will be able to break out of this process. As you can see over here, it has automatically thrown me out of this particular process because the container has stopped. Now we can see all the stopped container by doing docker ps-a command, and this will show you a list of all the containers that are either running or stopped. So as you can see, I have my container listed over here, and this is exited. Again, if you want to delete a container, you can do docker rm and then the container ID, and if you get to see the container ID printed, it indicates that the container has been deleted. Again, you can do docker ps-a and check for yourself if your container is still there or not. For me, it is gone. So this way you can get rid of docker container. Again, what we can do in this particular case is that first of all, we can go back to our docker file, and in this thing we can have one more command, expose and then 3000 port. Now this thing will not actually expose the 3000 port to the host machine. This is just there for the documentation purpose, because Docker CLI can show this thing that your application is actually running on 3000 ports. So it is just for the documentation purposes. It is not actually going to map the 3000 port on the Docker container to the port on the host machine. So keep that in mind. So we will use the expose command for the documentation, and then we will start our application using the previous command, but this time we will use -p in order to specify the port. So the host machine's port will go first. We want to serve this application on 8000 port on this host machine, and we want to map this 8000 port on the host machine to the 3000 port on the container. So this one is the host port, this one is the containers port. And also we would like to name our application something. We can name it using this name clause, and we can provide the name here, my node app. I can name it this thing, and I can start the application. Again, the application has been started. Now, since I mapped the application to 8000 port, I can go to 8000 and see if I can access it. Now, this is a classic express error, which means that the application is up. On this application, I have a route or root called anything. So let's see if I can access this anything route. If I do localhost anything, I will get this get response, which indicates that my server is running properly using the Docker container. So that is how you can containerize any application so that you can distribute it easily. You can put it onto Docker Hub for anyone to use, and then you can also give it to your IT guys so that it can be deployed easily. Now you must be wondering that this Docker thing looks very similar to a concept called virtual machine. So what is the difference between the two? Here the left side shows how Docker works, the right side shows how virtual machines work. So in case of Docker, it uses underlying OS in order to perform its duties. It is using the host OS's kernel in order to carry out the task. Now, in case of a virtual machine, you installed a guest operating system on top of the hypervisor, which creates an array of fake devices like CPUs, network drives, networks, and RAM, etc. And then you run your application on top of that guest OS. So this greatly increases the complexity of the system that is involved in running your application, because you are actually virtualizing an entire OS on top of the host OS. So you end up consuming a lot of resources, and this greatly improves the complexity of the system. So that is the difference. It is not actually using the underlying operating system capabilities in order to do its task. It is virtualizing every single thing. Here is a summarization of how Docker is different to VM. Docker uses host OS, VM uses virtualized OSs. Then Docker starts quickly because Docker does not have to boot anything, can simply create namespaces and C group and use the already running kernel in order to do its job. On the other hand, VM starts slowly because they have to boot the guest OS and then they have to boot the applications. That thing takes time. Then again, Docker use less resources because it is not virtualizing too many things. It is simply virtualizing namespaces and C groups, or you can say some part of the application stack. On the other hand, VM virtualizes everything. That is why it is resource intensive, because it is required to boot up an entire fake infrastructure and then boot up guest OS on top of that infrastructure. That is why it takes a lot of resources. And that brings us to the conclusion of this video. I hope this video was beneficial to you. This video was specifically created for web developers. I will create one more follow-up video where I will dive deep into Docker images and also talk about Docker Compose, because in a real world, you will not be using a single container in order to run your application. You most probably will be using an array of containers. For example, if you have a full stack application, you will have a container for your Express application, a container for your database, and a container for your front-end application. So that would be like 3 containers for running your full stack application. How can you create that sort of infrastructure? That will be covered in the next video. So make sure you give this video a thumbs up so as to give me a clear indication that you guys want that stuff. And also make sure that you subscribe to this channel, because I like working on such stuff for you guys. And when you guys enjoy it, that gives me a real kick. And I see you guys over in the next video. Take care. Bye.